This is Chapter 5, which deals with the integumentary system. The integumentary system is the skin and everything associated with it. The layers of the skin, it's divided into 3 layers. You have the epidermis, the dermis, and the hypodermis. Now, I'll tell you right now, the hypodermis is usually studied with the integumentary system, though technically it's not part of it. It's kind of one of those situations where it's the layer beneath the skin that connects the skin to everything else below it, but it's not really part of it. But where do we put it? Because it's not really part of any system. So this is a cross-section of the skin. We're going to look at the different layers. So the most superficial layer up here is the epidermis. Below that's the dermis, and then here's that hypodermis I was just talking about. Hypodermis tends to have a lot of your fat cells in there for cushioning, insulation. Notice the nice blood supply through the hypodermis, continuing up through the dermal layer, but notice it is not present in the epidermis, so we're going to talk about that. We're also going to talk about some of what's known as accessory structures, things like your nails, your hair, things like sweat glands and oil glands. All these are accessory structures as well. So we'll start with the epidermis. It's the most superficial layer, as I just said. It is stratified squamous epithelium, so that means it's multi-layered. Squamous is those flattened, they look kind of squashed type cells, and they're keratinized. Keratin is a protein that's going to be made initially as these cells are being produced. We'll see they're going to be pushed from beneath or be pushed up towards the surface, and as they are pushed up, this protein keratin is added to it. It's going to help give properties of strength and also kind of a waterproofing characteristic to the skin. It's a protective thing. It makes it more difficult for things to penetrate through the skin. Now, most areas of the body have 4 layers of the epidermis. However, there are some areas that are known as thick skin that have 5 layers. Things like the main areas are the soles of the feet and the palms of the hand, but also your digits. Now, the epidermis is avascular, so it does not have blood supply in it. It's dependent upon underlying tissues and the blood supply there to provide the nutrients, gases that it needs. It does, though, have nerves in it, so we say it is innervated. The layers of the epidermis are the stratum basale, and these layers, I'm telling you, are going from the deep to more superficial. Then the stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. Now the stratum lucidum, as you can see, that is the layer that is only found in the thick skin. So here in the schematic drawing, it is showing the different layers over here on the left. So down at the very bottom here in this little pink area down here, this is actually the dermis. You have these little ridges that extend up into the epidermal area. In the stratum basale down here, we do have melanocytes. We'll talk about this in just a moment. They're going to be producing a pigment called melanin. So the cells down here are going to be actively going through mitosis and dividing, and one cell stays down here and the others get pushed up. So by the time you're on the surface, these cells are dead. So the stratum basale, that is the deepest layer. The basal cell is the stem cell. And so it's going to go through mitosis very quickly. One cell remains. The other daughter cell will be pushed upwards. The cell that remains goes through mitosis, pushes one cell up, one remains. It just keeps going at a fairly rapid rate compared to other areas of the body. Now, there are other cells, as you saw in that previous picture, that are embedded in this layer. You do have Merkel cells. These are a sensory receptor. And then the melanocytes do produce that pigment melanin. Melanin, we're going to see again, it does help protect the cell, protects the DNA from UV penetration. The stratum spinosum is the second layer. It's often characterized as looking kind of spiny when you look at it. Under the microscope, the cells have this characteristic look to them. It's about 8 to 10 layers that of the keratinocytes. You do have dendritic cells embedded in here. Dendritic cells are also known as Langerhans cells, and these are capable of carrying out phagocytosis. That is a protective mechanism. They're able to kind of move around through the layers to detect any type of foreign debris. They can distinguish between cells that are yours and foreign cells. We refer to self versus non-self. So these Langerhans cells are kind of on patrol, searching for anything that may have penetrated down to this layer. The stratum granulosum, the name implies it kind of has a grainy look to it. It's about 3 to 5 layers thick. Cells, as they're in this layer, are going to die, and the nucleus is going to start to break down. The organelles are going to start break down, and that's why it's getting this kind of grainy look to it as things are breaking down in the cell. Part of the reason the cells are dying is they are far enough away now from that stratum basale where beneath that is the dermis, which has the blood supply. So it's too far for the nutrients and the oxygen to diffuse through. So they're not getting the nutrients. So essentially it's kind of like they're starving to death and they're going to start to die. At this point, you do have that protein keratin present, which does give the waterproof properties to the skin. That's going to help keep you from getting dehydrated. The stratum lucidum is that extra layer that's only found in the palms of the hands, soles of the feet, the digits, areas that get a lot of wear and tear. They kind of need that extra layer of protection. It's very smooth, it looks translucent. And then the outermost layer on the surface of the skin is the stratum corneum. It's about 15 to 30 layers thick. It's composed of layers of dry and dead cells. This provides protection. Once again, it's going to help prevent dehydration from occurring. How does it protect? Well, anything to penetrate the body has to penetrate through it. And oftentimes these cells start sloughing off. So let's say a bacteria lands on your skin, which they do. When the dead cells are being sloughed off, the bacteria on them get sloughed off as well. It's been estimated from the time a cell leaves that stratum basal layer when it's first produced to the time it reaches up to the surface and is sloughed off, can be anywhere from 25 to 45 days. There are different factors that can influence the timing of it. But essentially, yes, what you're looking at when you look at each other, it's mostly dead cells. And the skin's constantly regenerating, if you will, and those dead cells are sloughing off. The dermis is below the epidermis. It is vascular, so it does have a very healthy blood supply to it. The epidermis was made up of, remember, epithelium tissue, that stratified squamous epithelium tissue. The dermis is connective tissue, and it can also be divided into 2 layers, the papillary layer and the reticular layer. The papillary layer is composed of loose areolar connective tissue. It is right beneath the stratum basal, so it's right below the epidermis. It does form these dermal papillae, these little, it's not a smooth surface, it's these little ridges and invaginations that ultimately are going to be forming things like your fingerprints. It helps to increase the surface area between the dermis and the epidermis. Whenever you increase surface area, it allows for more like diffusion to occur, etc. Within the papillary layer, you're going to have fibroblasts that are making those fibers, protein fibers that you find in the connective tissue. Remember, has extracellular matrix, and part of that is composed of fibers that are made by the fibroblasts. Adipocytes, these are essentially your fat cells. It does have a lot of blood vessels. It does have a lot of phagocytes, those different types of cells that are capable of recognizing foreign debris. They also, if there's been an injury, they'll clear up any dead cells. You have lymphatic capillaries, you have nerve fibers, you have sensory receptors in here. So there's quite a bit of other cells that are associated within the dermis layer. The reticular layer is still connective tissue, but it is dense, irregular connective tissue. Once again, it's highly vascular and it's highly innervated. Innervated means it has nerves running through it. And so in this diagram, cross section here, the very top you have the epidermis, so the dead corneum layer here. Here's where your cells are actively growing, this darker pink. So this would be the basal layer. The lighter pink on the lower area now is the dermis. And you can see kind of the difference in the way it looks. And these shown here, the papillary. This is the dermal papillae I'm talking about, these where it increases the surface area. The hypodermis, as I mentioned at the beginning, is not technically part of the integument, but we throw it in here because, once again, where are we supposed to put it? Please know that depending on what book you look at, some books call it the hypodermis, some will call it the subcutaneous layer, and sometimes it is called the superficial fascia. They're all the same thing. It's one of those things, it's just kind of a personal preference. So any of those terms would be correct. It is highly vascular. It is composed of loose areolar connective tissue similar to what you see in the papillary layer, but it also has a lot of adipose tissue. Adipose tissue is fat tissue, and that's going to help provide a lot of insulation and cushioning. So it helps secure the skin to the underlying tissues, but it also helps protect the underlying tissues as well. The skin color, pigmentation of the skin. One of the major pigments is going to be melanin. That's produced by those melanocytes that are down by the stratum basal layer. Now, the melanin is going to be taken up by the various keratinocytes, the various cells there, and as those cells move up towards the surface, they have the melanin in them. What's the purpose? Well, it helps protect the DNA from UV light. It can interfere with vitamin D production, which we'll talk about at the end of this chapter. Now, difference in the amount of production, some of that is environmental, some of that is genetic. One thing, if you notice from an evolutionary standpoint, individuals who are from areas closer to the equator where the sun is more intense tend to naturally have a darker pigmentation of their skin. Why? Because they tend to be producing more melanin. But that's a protective mechanism because your exposure to UV light is greater and more intense. And so melanin is kind of like the body's sunblock, if you will. It is a protective mechanism. Another thing that is involved with pigmentation in skin is keratin. Keratin is found in your yellow and orange vegetables. It gives it that yellow-orange color, like pumpkin, squash, sweet potatoes, yams, things like that. Keratin is important in terms of it is a precursor to making vitamin A. You do need vitamin A. It does assist with the process of allowing you to see. So your mom was right. She said you had to eat your carrots because that would help with your vision. As a kid, my mother always told me that, and I love carrots, and I used to eat a whole bunch, and I still ended up with glasses, which I reminded her of frequently. Keratin, you're thinking, okay, fine, so it's squash and pumpkin. How can that affect pigmentation? This is more obvious with someone who's very fair-skinned, and some of you may have seen that if you have children. When you have a young infant and you start them on their solid foods, those of you who have kids are familiar with this, you kind of start them, it seems like, on colors. And when you hit the carrots and the sweet potatoes and you're introducing them to them and they're eating more of that, if the young child is very fair-skinned, like my kid. I'm of Irish background. I'm very fair-skinned. So what happens oftentimes is that carotene tends to accumulate in certain areas, sometimes on the hands. One area, especially, it seems like with little kids, is in the nose if you're really fair-skinned. Now, if you're darker skinned, it's not going to be as obvious. But I remember with my kids, taking them for checkups, the pediatrician was like, oh, I see you've introduced the yellow vegetables because the nose is a little bit orangish here. Yep. Hemoglobin is another pigment that can help with coloration of the skin. Hemoglobin is found in the blood. It binds oxygen, and it gives, when it's bound with oxygen, it causes that red, bright red color. Once again, someone who's very fair-skinned, if you have increased, say, blood flow to the surface of your face is going to look red then. It gives it more of a pinkish red hue to it. So melanin is going to be the strongest pigment that has influence on skin color, but know that there are other pigments as well, the carotene and hemoglobin, that can also affect skin coloring. And this diagram is just showing down here in the what would be the stratum basal layer, these cells are going through the mitosis like they're supposed to. But here is one of your melanocytes. And so everyone tends to have roughly the same number of melanocytes. It's just how much melanin is each one producing. So like I said, I'm very fair skinned, so I'm going to be over here. My melanocytes don't work real well, if you want to think of it that way. They're not producing very much pigment. Someone who's darker skinned, the melanocytes are producing a lot of the melanin. And see how that pigment becomes incorporated. It's taken up into those keratinocytes. So as they move towards the surface, by the time you get up here, you have a lot of melanin in the cells, which gives the darker coloration to the skin. Now, the accessory structures associated with the integumentary system are the hair, the nails, the sweat glands, and the sebaceous glands. The hair. Basically, these are dead cells too. So not only is your skin dead that you see, but the hair that you see is dead. So sorry, most of what you're seeing is dead. Now, with the hair, we like to divide everything up and, of course, give everything different names. So the hair shaft is the portion of the hair that's above the surface of the skin. So that's what you see. The portion that's below the skin, we call the hair root. Is it still part of the same strand of hair? Yes, it is, but get used to it in biology. We want to annoy you, so we're going to give it the different sections different names. So the shaft is what you see. The root is below the skin surface. There is an area of connective tissue that has a lot of blood capillaries and nerves to provide the growing cells of the hair, and that's called the hair papillae. Surrounding that is the hair bulb. That's a group of cells surrounding it to protect the blood vessels and the nerves. The hair matrix, that's the basal cells that are actively going through mitosis to produce new hair cells. As they go through mitosis, the new daughter cells are going to be pushed up or further away from them. Well, those cells that are actively going through mitosis, they need to have a good blood supply, so the hair matrix is going to be right near the papillae. And then the hair follicle, this is actually the sac where the hair originates. So here's a picture, and this might make it a little bit more sense to you. Excuse me. So the shaft is what you see, the root is below. The hair follicle is kind of the sac area that's holding the hair itself. The hair bulb is around this papillae area down here where you've got blood vessels coming in. The hair matrix is where the cells are actively dividing. So they need nutrients from the blood. They need oxygen from the blood. So that's why you have this good supply right here. The bulb is around protecting all this because these cells are actively growing and they're pushing the cells up. And then by the time they get up here, those cells are dead. Notice this is the erector pili muscle. When this muscle contracts, it's going to pull this strand of hair straight up, and that's what gives you goosebumps. This is a smooth muscle, so you have no control over it. And then here is the sebaceous gland. We will talk about that in just a moment. The functions of the hair, there are several of them: protection, thermoregulation, sensory input, communication. Protection, a lot of sensitive areas of the body are covered with hair, such as your head, prevents you from getting sunburn. It also helps to keep some of the heat in. It's involved with thermoregulation in terms of when you sweat, oftentimes sweat glands and oil glands are associated with or near the hair follicles. And so when you sweat, it's going to help cool you down. So we'll talk about that in a moment. The hair, in terms of sensory input and communication, they're very sensitive, even though the cells are dead. All of you have had situations where you can kind of feel something walking across because it's disrupting the way the hair is. So maybe you feel something walking across your scalp because you can feel the hair moving. That's a way of alerting you to checking out something's not quite the way it should be. And so it does have this way of receiving these sensations and then sending the information to the brain as to whether or not you need to respond to it or not. The nails, another accessory structure. Nails are there for protection, as you notice on your fingertips and your toes, areas that oftentimes receive a lot of abuse. So the ends of those have the nails on it for protection. The nail root is the area where the cells are actively dividing. And then you do, to hold the nail in place, the nail root is below the skin so you don't actually see it. And then the cells are pushed out as the nail grows. Now, the nail folds will help hold the nail in place. You have the lateral nail folds on either side of the nail, and then you have the proximal nail fold, which is also known as the epinicium, which is also known as the cuticle, and they all work together, like I say, to hold that nail in place. Underneath the nail is very rich blood supply, and that's why it has that pinkish color to it. And so as you can see here, you have got the folds, like I say, that are helping to hold the nail in place, and that nail root is underneath here, underneath below the cuticle, because cuticle's up here. And so the cells are actively growing here, and as you know, pushing the nail out this way. Nails can be very critical in a couple things. The condition of the nails and any abnormalities can give us clues for certain diseases and disorders. So oftentimes we will look at, as healthcare professionals, we will look at the nails to give us an idea. Are there any clues there? Also, a lot of chemicals, toxins can become accumulated in the nails as well as in the hair, which is why from a forensic standpoint, if it is a questionable death, an autopsy, they will take sample of the hair and sample of the nails and do toxicology screens on them, because chemicals such as, say, arsenic will accumulate in both of these accessory structures. And because it takes a while for it to grow, you can see whether if somebody was exposed to a toxin, maybe not yesterday, but a month ago, 2 months ago, depending on how long it takes their hair and their nails to grow, you can possibly pick that up. Sweat glands are known as pseudorefrous glands. There's two different types of them. There's eccrine and apocrine. Eccrine ones, the sweat's mostly water. It's going to be involved with thermoregulation. They're found all over the body, but there are higher concentrations of them in the forehead, your palms, and the soles of your feet. When you are hot, when your internal body temperature starts rising, it's constantly being monitored, and there's a range that it's like, okay, but if it gets to a certain point, the body's going to respond to try to bring your internal body temperature back down to a more normal range. And one way of responding is to activate the sweat glands, the eccrine sweat glands. Now, as much as you may not like it that you are sweating, it is the body's natural way of regulating your internal body temperature, because when you sweat and that water evaporates, it's carrying heat with it. So that helps to cool you down. So it's very, very important with this thermoregulation. One thing I will just say is kind of for your own information. One problem that happens in some areas here in the area of East Texas where our humidity is fairly high, you know when you're sweating. I mean, you all know that. In some areas, like in the southwestern part of the U.S., where it is very, very dry, very low humidity. When I was living in New Mexico, there were plenty of times when the humidity was 10%. There were times I can remember when it was in single digits. It's very dry. When you live there, you get used to it. You learn to drink lots of water to replenish so you don't become dehydrated. There is a problem that often happens when people first move there or for tourists who are visiting. It's that if they are out visiting different sites, doing whatever outside, it's hot, you're still sweating, but when the humidity is only, say, 7% and you sweat, it immediately evaporates. So you are not aware that you are sweating, but you're still losing that fluid. And it's very easy for people to get dehydrated and to the point where it becomes a very dangerous situation. And so oftentimes people say, oh, well, it doesn't feel that hot. I don't think I'm sweating. Yes, you are. So it's just something to be aware of. Who knows where you guys may end up working and or even traveling on vacation. When it's hot, your body's going to sweat. You may not always be aware of it, but it's going to sweat. Apocrine sweat glands. In this case, with these sweat glands, the sweat has water in it, but it also has organic compounds in it. And bacteria. Your body is covered with bacteria, and it's supposed to be. That's the natural way it is. But a lot of these bacteria like those organic compounds, and so they will break them down, and it's the byproducts that give that smelly sweat odor. So blame the bacteria. I know as a microbiologist, those microorganisms get all the bad rap. In this case, it's kind of justified. They like the organic compounds. They think it's smorgasbord, let's chow down, but their end products are not so nice for us to be around. Apocrine sweat glands tend to be found in the armpits and genital regions. They're not as active in children, but when you hit puberty, that's when they start becoming more active. So this picture is showing an example of an eccrine sweat gland. It is a type of exocrine sweat gland in terms of you've got the gland here, and then you have this duct, and it is going to open up through an opening or a pore on the surface of the skin. It is not associated with the hair. It is separate from it. So when you're looking at a cross section and you see something like this is a eccrine sweat gland. Sebaceous glands are oil glands. They are usually associated with the hair follicles now. They will secrete sebum, which contains a lot of lipids. Remember, lipids are fat compounds. This helps to lubricate both the skin and the hair. It helps provides waterproofing properties or assist with that for the skin and hair. And you might think, oh, sebaceous glands, oils, yeah, if they're too overly active, it's not so fun, but you do want to have some of them because it does help make the skin and the hair nice and soft and pliable. And so these are the ones that are associated right here. They will produce that sebum, and then they're associated with the hair, and they will drain in along here and then release it out through. So they don't have their own little ductwork like the eccrine sweat glands do. So sebaceous glands, think oil glands. Think of them associated with the hair. So what are the overall functions of the integumentary system? Well, there are several of them. Number one, protection, sensory function, thermoregulation, vitamin D synthesis. They help prevent dehydration, and for insulation. So for protection, it helps to prevent that dehydration because of the waterproofing properties. It's helping to keep as much of the water and moisture internal and not just having it drain out of you from your skin. It's also a physical barrier. We see this certainly when we talk about your immunity and protection from infection and such. Anything that has to try to penetrate inside of you has to get past the skin first. So it's an actual physical barrier. It also is a chemical barrier in that it will release certain chemicals that have what we call bactericidal properties. Bactericidal properties means that it will kill bacteria. So there are certain chemicals in the oils that we mentioned that are secreted by the sebaceous glands that have these properties that will help kill bacteria. So it's kind of like, okay, I'm going to hit you with the 1-2 punch because I don't want you entering inside this body. So I've got this physical barrier, and if you think you can get past that, then we're also going to release chemicals that will kill you. Now, just so you know, as a microbiologist, microorganisms, your bacteria, your fungi, they sometimes have developed ways of, you think that's going to stop me? I have a way of getting around it. Sensory function. There are a lot of receptors that are embedded within both the epidermis and the dermal layers. These are very specific so that if you have a sensory receptor that can detect touch, it will not detect temperature changes. If it detects cold temperature, that's all it detects. It would be a separate one that would detect warm temperature. Touch, light touch versus deep pressure, pain. All these receptors are very, very specific for it. Some examples, the Messenger corpuscle, that detects light touch, but the Pacinian corpuscle will detect vibrations. And then your Merkel cells also are touch receptors. All of these are important from the standpoint of making you aware of your surroundings. Is it something that you need to be aware of and respond to, or is it okay, well, let's just know there's some touch there, but I don't have to worry about it, or there is a spider that is walking across my arm and I don't want it there. Thermoregulation, we talked about this with the sweat glands, how they'll be activated as your internal body temperature rises as a means of trying to cool you off. Another thing that happens, and this is an example of how we study these systems separately, but they do work together and they have to communicate with each other. You have those blood vessels that are coming into the dermal layer. Now remember, they don't go up to the epidermis. They're just right beneath it in the dermal layer. When the internal temperature rises, those blood vessels are going to dilate so that it increases the blood flow to the surface, and that's going to help dissipate the heat. Now, the reverse happens when the internal body temperature starts to drop. When you're really cold, you're trying to conserve heat, and so at that point, the blood vessels in the dermis are going to constrict to decrease the blood flow. They're not going to stop it completely. They just are going to decrease it, and that way it's trying to conserve some of the heat. So it's certainly an example of how the circulatory system is going to be working with the integumentary system to regulate your internal body temperature. And how does the blood vessel know whether to dilate or constrict? It's getting information from some of those sensory receptors. Oh, it's getting cold, not only on the surface of the skin, but internally. It's going to involve the nervous system that takes that information, sends it to the brain. The brain's got to decide, what do we do? Okay, now let's activate the blood vessels, send the message there to dilate or constrict depending on the conditions. So it's like everybody has to be communicating with each other to get your appropriate response. And this is showing over here what we were just talking about, is that when it's cold, so here's the epidermis, here's the dermis here, here's your blood supply coming in. You're not shutting it off completely, but you're constricting and decreasing the flow. That way you're not up on the surface and losing that heat. But when you're hot, now you do want the flow all the way up here. Increase that flow so the heat can dissipate out. For vitamin D synthesis, vitamin D is necessary for calcium absorption. Vitamin D also plays a role with your immune system. So calcium is necessary for things such as nerve impulses, muscle contraction. So you have to have calcium. You can take all the calcium in your diet, but if there's no vitamin D, you're not going to absorb any of it. So you have to have vitamin D in order to absorb that calcium. So how does this involve the skin? Well, there is a precursor to vitamin D that's found in the skin, and it's made from cholesterol. So you start with cholesterol, you add different other chemicals to it. So this cholesterol derivative, when UV light that's found in your skin, when UV light hits your skin, it converts this cholesterol derivative to cholecalciferol, which is known as vitamin D3. That then moves from the skin to the liver, and it's going to be now converted to calcidiol. That's now going to move to the kidney, where the calcidiol is converted to calcitriol, which is the active form of vitamin D. So you start with a precursor, if you will, over here. If you want to think of it, first step in your skin, UV light hits here, converts to this intermediate, which then goes to the liver, and it's converted to intermediate number 2, which then goes to the kidney and gets converted to this final product. This is the final form of vitamin D. This is what you need now to help absorb the calcium. So if you don't have this, you're not going to be absorbing calcium. And where did this come from? Over here, which zigzags back to the UV exposure. So the lack of vitamin D is going to mean you're not absorbing enough calcium, which, as I said, is going to affect things such as nerve impulses, muscle contractions. You store excess calcium in the bones, which means if you're not getting enough calcium, you're going to end up with bone deformities. And usually you end up with a disease called rickets, which is caused by lack of calcium. There is a catch here that you need to have that exposure to the UV light in order to have the whole process start and basically synthesize vitamin D. However, you don't want excessive UV light because as we'll see in a bit, that can lead to skin cancer. So there's kind of a balance here that you have to be aware of. And so it's a balance. Just to give you a personal example, I have had several rounds of basal cell skin cancer. I'm very fair skin, which puts me at high risk. It runs in my family, and like I say, I've already had skin cancer. So my doctor has finally said the risk for me of exposure UV light for skin cancer is too high, but I need to get the vitamin D. So I now have to take a vitamin D supplement in order to have enough vitamin D so I can absorb the calcium that's needed. So what are some of the diseases of the integumentary system? Well, skin cancers, I just mentioned a little bit. There's three main types of skin cancer: basal cell carcinoma, carcinoma is cancer, squamous cell carcinoma, and melanoma. Basal cell carcinoma is one of the most common types of cancer, of any of the types of cancer, and certainly of skin cancer. It is typically non-invasive, so it doesn't metastasize, it doesn't spread to other organs. You still want to have it treated though. It originates with the stratum basal layer. You can easily have it treated. Oftentimes they'll freeze it off or by surgery cut it out. It may look like a slight discoloration of your skin. I always say, you know what's normal for you, so if you start noticing things that are abnormal, get it checked out. Squamous cell carcinoma, it originates in the stratum spinosum, and it can metastasize, so you definitely want to get this one treated. You want to get any of them treated, obviously. Melanoma is the most severe. It can definitely metastasize. Sometimes it can be aggressive. It originates with the melanocytes. This is an example here of melanoma. It can take on several different appearances. Melanoma definitely has been associated with exposure to sunlight, but also there can be other contributing factors. One thing I do want to say is some people realize, oh, melanoma can be triggered by exposure to sunlight, but I want a really nice tan, so I'm going to use the tanning booth. Tanning booths can be just as dangerous, and some people have actually said they feel the risk is higher with a tanning booth. It's just not worth it, folks. So with skin cancer, they usually will talk about A, B, C, D of things that you look at. Some people have extended that and added some additional things to look at. And some of these people would just combine with the A, B, C, D. Asymmetry. Look, if you have a spot, it may be a mole. Moles by themselves usually are not a problem. It's when they change that you should be concerned. If you have a mole that's always looked one way and then suddenly it starts growing or it changes color, you need to have that checked out. So the ABCD for cancer look at asymmetry. Do you have a spot and it's not perfectly even? One side does not look like a mirror image of the other. Get it checked out. Look at the border. In that last picture we saw, the border there is very irregular. So if it's not a nice smooth border, most moles will have a smooth border. If it's irregular, get it checked out. The color. If it's a dark brown, black, or if the color changes, get it checked out. Look at the size of it. If the diameter is greater than 6 millimeters, get it checked out. Okay? Now the E, if it's evolving, if it's changed, that shape has changed in any way, get it checked out. If it's raised, get it checked out. If it's kind of been soft but it suddenly becomes very tough and firm, get it checked out. And certainly, obviously, if it's growing, get it checked out. You would rather get something checked out and someone say, oh, that's nothing, than to not do anything and then be too late. There's a lot of different skin disorders. We're just going to talk about a few of them. Eczema is an allergic reaction. It results with very dry, very itchy patches of skin, not the entire, but just patches, so it often looks like a rash. Acne is when there's an overproduction of sebum in that sebaceous gland, that oil gland, and because you have an overproduction, it accumulates and it blocks that hair follicle. So now you're still producing and overproducing, but it's blocked. It cannot drain out the way it normally would. And then this sets up for a bacterial infection. So initially here you've plugged this, where the hair follicle is. Here's the sebaceous gland. It's still producing that sebum, but it's blocked right here. So you're still producing. You're still producing. You're starting to get a mild inflammation, maybe a little bit of pain, a little bit of redness, because the sebum has no place to go. And now what happens is bacteria are like, oh, lunchtime. The sebum's got lipids in it. We can start eating this. And then you end up with the infection. One of the signs of infection is inflammation, so you definitely get reddening. It's going to be sore. You've got all this sebum here. It's pushing up, providing pressure, and that's what acne is. Different types of injuries to the skin. Some examples of burns, scars, keloids, bedsores, stretch marks, and calluses. Burns. Some things that you're very concerned about, especially with a severe burn, is dehydration of the individual. You've destroyed part of the skin, and so you're worried about that protective physical barrier has been basically destroyed. The integrity of it has been lost, and so now you are susceptible to dehydration and that water loss. You're susceptible to an electrolyte imbalance. You're losing not only the water, but potentially the sodium, the potassium. Those are supposed to be kept within certain ranges within the body, and if you're losing that, you're going to end up with an imbalance, and then that can cause additional problems. Because of the dehydration, because of the electrolyte imbalance, the shock to the system, you could, in very severe cases, end up with renal failure, renals, kidneys, so kidney failure, and circulatory failure. And obviously, another huge concern is infection. With burns, we talk about the rule of nines to try to figure out the severity of it. The body is divided into different sections, and each section is basically 9%. And so it allows you to figure out very quickly what percentage of the body has been affected by the burn. We classify the burns as first, second, third, and sometimes fourth degree. First degree burn is only going to affect the epidermis. So it's the least severe of them. You're going to feel it. You're going to be uncomfortable because there are nerve endings in epidermis. Second degree burn, it affects the epidermis and also part of the dermis. Not all of it, just part of it. And this is where if you get blistering, that's a second degree burn. Once again, because of all those sensory receptors, you're going to feel it. A third degree burn affects the epidermis and now all of the dermal layer. It has destroyed the nerve endings. It's destroyed all that sensory functioning. So you're actually probably not going to be in pain. You're very severe burn, and you certainly are going to be worried about dehydration, electrolyte imbalance, infection. But as far as the patient, because you've destroyed the nerves, it's actually not going to be painful. Now, it will later as the nerves on the ends can start to regenerate. That's when it's going to be painful. Fourth degree burn is when it actually affects the muscle and the bone underneath the skin. Scars and keloid scars, it's just basically when you had an injury and the skin repairs itself, but that damaged skin area did not repair to the original structure of the skin in that area. And a keloid is simply a raised scar because you've had overproduction of the scar tissue. Bed sores are caused by excessive pressure to an area, and it's when there's constant long-term pressure on the body. This becomes a problem. It's a danger that you must be aware of when you have a patient who is immobile. Someone who is bedridden, you must turn that patient so they are not always lying in exactly the same spot, because that's going to put pressure on the exact same spot and could lead to bed sores, which then can lead to infections, very difficult for them to heal, etc. So don't even let them get started. Stretch marks. This is when the dermal layer gets stretched beyond its limit. It's very common in pregnancy because of the increased weight. And the skin is stretching due to the extra pressure, and it's often stretched, like I say, beyond its limits. Sometimes this happens in puberty if you have very rapid growth. The stretch marks over time will often get kind of fade and get lighter and lighter, but they're there. And then a callus, this is formed because you have constant abrasion or pressure at a certain site, and what happens is the stratum basal cells are going to start dividing even more frequently, trying to add extra protection to that area, so you get kind of a thicker growth in that area. One other thing that I did not mention, but just FYI for paper cuts. With the skin, because there is no blood supply to the epidermis, if you get, say, a paper cut, you're going to feel it. You've all had one. You feel it. Why is it that sometimes they bleed and sometimes they don't? If it does not bleed, that means that you only cut through the epidermis. You did not reach the dermis. If you reach the dermis, then it's going to bleed. But why did you feel it? Because you have free nerve endings that extend up into the epidermis. So no matter what, you're going to feel it. Whether it bleeds or not depends on whether you got down to the dermal layer or not. So that is the integumentary system.